In many species of trees, there has evolved a partnership called mycorrhizae. Myco means fungus and rhiza means root. The little strands of fungi can actually grow into the root itself, or in some cases make a little sheath or covering around the tip of that root.
The big thing is not in the canopy itself, but it is in the roots of the system of the forest. It is in the mycorrhiza. And the mycorrhiza exists in a sandwich.
Basically, trees can carry out photosynthesis, so they can happily capture energy from the sun and then store it in their leaves or their trunks or their roots. Fungi, on the other hand, cannot. They have no chlorophyll. They cannot do photosynthesis. However, they are very good at permeating through the soil and gathering nutrients from that soil.
They trade. The tree and the fungus trade. The tree provides carbon, and in return the fungus will grow through the soil and access nutrients and water and bring it back to the tree. And so they both benefit. And yeah, so the reason the tree does this is because it costs less energy to associate with these fungi than to do it on their own. And the fungi can grow into really small spaces.
People really didn't understand how common these mycorrhizal relationships and associations are until about 20 or 30 years ago. They just didn't get it. They didn't, because it's hard to see, especially when you get the type of mycorrhizae that live inside the roots. You have to look at these roots underneath a microscope. You have to stain them with a fungus-specific stain. You have to look for these little characteristics and structures that are inside the root, because the root looks very normal.
There will be a Nobel Prize waiting for somebody who understands this in the whole mycorrhizal work of the tree. And it's far greater underneath the soil of the tree. You look at the tree, you see the canopy and the stem, and then you see you are aware that you're standing on the root system. But the root system of a tree is enormous.